All right, we should be on this page here. And we are going to be doing a little bit with proofs again today, but focusing on those similarity tests that we talked about on Friday. So side, 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 and angle, angle. So just like when we were doing congruent triangle proofs, we were trying to use those 5 congruence tests that we reviewed on Friday, like side, 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 angle, side, angle, all of those. If we could get our way to saying, Austin, if we could get our way at the very end to showing that those 2 triangles satisfied one of those 5 tests, we were then able to kind of finish our proof. So today, in order to know that we're done with our proof, we want to get to angle, side, 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 or side, angle, side. If you are trying to use a proof with these 2 tests here, the ones that involve sides, if they're giving you numerical values for sides, you will have to check that they're proportional. So I'm just going to write that as a note up here at the top. If you're given numerical values for sides, you have to check if they are proportional. To use these tests. You don't have to do that for angle because angle isn't working with the sides. And so if we can show or have information that allows us to know that 2 out of the 3 angles are congruent to each other, we don't have to worry about checking if sides are proportional. Now, if they only give you 1 angle, but then also on the triangle you start to see, oh, they're saying that this side's 10 and this one's 5, and they're saying this one's 14 and this one's 7, we have to check that those would break down to the same amount. So in that case, they would both break down to 2 or a half, depending on how you set up your proportion. Just like what we were doing on our bell ringer or what you guys did on your worksheet from last week. So if you see that, you're going to want to make sure you do that. Now, most of the examples I give you guys today aren't going to have side lengths. They're just going to be mainly focusing on angles and being able to show why the triangles are similar using angle here. Most of these proofs are going to be fairly short, like 4 or 3 steps. So they're not going to be super long like we did with congruent. Some of those congruent triangles got really lengthy when you especially had to end with like the CPC-TC stuff. You won't really see a whole lot of that today. So these proofs should be fairly short when you're trying to kind of think about your number of steps. Okay, what do you guys always start with? The given, which they kind of have filled out for us already. So they're giving you the fact that angle A is congruent to angle D on this first one. And they do already have that marked for me in my picture. Now, again, they're going to mark those angles differently. Like they've got symbols on this one. They could be using arcs. It just depends on what they decide they want to use. But this one has those 2 open circles. So I have 1 angle marked. Now, I don't have anything about the sides. Like there's no numbers involved on the sides. So I'm probably not trying to use side, 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 or side, angle, side, which means I'm trying to find another angle. Where's it at? Keegan? The vertical angle's in the middle, okay? So he's talking about this one here. I'll just put a closed circle by it, and this one here. Can I just say angle B? Why not? How many angles are technically starting with angle B as a vertex?
4.
There's 4 total there because it goes all the way around. Now, the 2 we're focused on are the vertical angles, but remember, this side would also have B and this side would also have B. I don't really care about those right now, okay? But those would still be there in the picture. So I can't just say angle B. So how could we name the top one, the little triangle one? CBD. So angle CBD would be congruent to EBA. Very good. Order still matters. We have to make sure that we're keeping like things together. So C and E are both unmarked, so they need to go together. The B, of course, is going to be shared in the middle. And then D and A were the ones that we started out with. So those have to go together in your name. And then we said our reason was because these are vertical angles. do I have two angles that are congruent here? So it should be enough to say these triangles are similar because of my angle-angle test. I have two of my angles marked, so I'm just going to end it here with my prove statement, which I'm already just going to use that triangle statement they have up there. I'm not going to think too hard about that. So ABE is similar to triangle DBC because of angle-angle. So really similar to what we did with congruence, but we're not talking about congruent anymore. We're just talking about the fact that these triangles are similar to each other. A dilation has occurred here in order to make these triangles look alike. All right, questions on that first one? Okay, let's take a look at the next one then. Again, they already put all the given information down here for us. I'm just going to number them. And if you need to, you guys can draw a line down if you need some like separation or organization, if that's something that you helps you kind of keep track of your steps, you can do that. You also could draw a line here if you want to really organize your boxes a little bit. Okay, so we are given that in the triangles ADC and BEA, there's right angles in there, which they do have marked with those boxes in the picture. Now, this picture here, the triangles that we're looking at are overlapping. So the first one that they have down here in my proof statement is triangle ADC. So I'm just going to highlight that one. So that would be this triangle. And then the other one is AEB, which would be this one here. Those are the two that we're trying to show are similar to each other. Okay. Now, if that's really confusing, you can pull them out and separate them. Just right underneath the picture, you could take out the ABE, and you know that there would be a little box by E there. And then the other one that you could pull out, and even if I just kind of flip it so it's maybe sitting upright, it's a little bit bigger. This would be, up here at the top would be your C, and then this would be D, and this would be A. So you could do that if you needed to, just so you can really see what two triangles am I working with here, but understand that they come from an overlapping picture. And we need to maybe use the fact that they overlap to help us solidify our proof. All right, so if I know that those angles are right angles, what does that mean about their measurement, like actual number? It's 90 degrees. And if they're both 90, that means that they'd have to be equal to each other. So they talk about them being right angles, but we probably should specify that means that they would be equal or congruent. So I'm going to go ahead and just branch off of my given here and say that those two angles, ADC and BEA, are congruent to each other because all right angles would be congruent. That's really similar to when we did our congruence proofs. If you had like midpoint, we had to say this segment is equal to this segment because of midpoint. Like we had to specify what was actually happening in the picture. So this is just taking what they gave me in the given and putting a numerical value behind it to actually back up why we know that they're equal to each other. All right, so that's one angle. Again, I'm not given any side length, so I'm probably not trying to use side, 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 or side angle, side. So I need another angle. What do you guys think we could do? Can it?
At the top, you could do that with congruent because of the bisector.
Are you talking about what line are you looking at for a bisector? Oh, I see what you're saying. Okay. So B, I mean, this line BE could be a bisector. I don't know for sure. And if it was, it would be talking about like maybe this angle up here. But like on this half, that's not in on my triangles that I like highlighted down here. So I don't know if I really want to use that. Yeah.
They share angle A.
They share angle A, is what she's saying. Do you guys all see what she means when she says that? Isn't that where they overlap? And when I drew them out separately, don't they both have an A in the names? So I think we should maybe use the fact that they overlap there to say that they're going to be congruent at that angle. Now, because it's just A, I can just say angle A. I don't have to name it two different ways because A is one point up there in my picture. There's only one angle coming off of A. There's not like other lines, like there's nothing going like this or like this off of that A that make me think about what angle I'm looking at. There's just the one. So I'm going to go ahead and say angle A is congruent to itself. What property do you guys think that is when something's equal to itself? Reflexive. Very good. Okay, and so you could mark that in either this picture up here, we could give this an arc, or you could even do it down here on those pictures that I separated out. So what can we do to finish this off? Angle is my reason, and what do I put for my statement? Very good. So in those pictures, especially when you're working with angles, look for vertical angles. Look for overlapping, angles that they share between the two of them. Those are going to be really helpful things. We've also talked about, like last week when we did some of those similarity triangles, we talked about parallel lines, and we had like alternate interior angles and corresponding angles show up. So if anything like vertical angles or overlapping or those angle pairs start to show up in your picture, or you think that you could maybe use them, maybe see if there's something in there that you could pull out and have you finish up your proof. Do we have questions on that second one? Okay, we've got one more here. Again, they already put our given down here for us. BC is parallel to EF, and we want to prove that these two angles are similar to each other. All right, anyone have thoughts on how we could maybe start? Colby, what do you think?
Angle A is equal to angle A.
Okay. Because why?
Reflexive.
Reflexive. I agree. Angle A up here, I'm just going to give it an arc, is the same for both triangles. Again, it's overlapping there, so that's why we can say that. So that's one angle. Do I have any side measurements at all here? No, I don't. So I'm probably not trying to use, again, side, 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 or side angle, side. We're back to angle here, but I need to find another pair of angles, and I need to have some reason for it. So what are they talking about in the given? Parallel lines. What did I just say from Friday? We even talked about this. What happens when we have parallel lines? Corresponding angles, or maybe alternate interior angles show up depending on how your picture is drawn. What kind of angles do you guys see on this picture? Corresponding. Can you kind of tell me where they are? Okay, so like B would be congruent to E, and like C would be congruent to F-ish, right? Now, when we name these, we probably need to be a little more specific with the names, only because if you guys look at B has like two halves to it. This is an angle where I put that dot, but then on the other side, almost think about like a linear pair here. Those are two angles coming off of B. So we probably need to name these a little bit more specifically. So give me a name with 3 letters for B. ABC. Angle ABC works, and that would be congruent to what? Whoops. ABC is congruent to AEF, you said? Because of corresponding. But again, did you have to use that one? No, you could have used the other side. So how would you name the other 2 angles if you wanted to? Good. I don't really care which one you guys give me there. Also, kind of a follow-up question to that. If I used both pairs of those corresponding angles, so if I only wrote down what I wrote down here in step number 3. Do I even need step number 2? Is this 2 angles? Yeah, so this alone would give me angle, angle. But it's okay that we did this one. But then you'd only need one of these. That's why I put that one in green as kind of like that's an optional thing to write down for this proof. But now if you were only using the corresponding angles, I need to see both of them because I need to see angle, angle somewhere. So now we should have enough to finish it. So we're going to say triangle ABC is similar to triangle AEF, again because of angle, angle. Now, none of those that I went through use side, 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 angle, side. That does not mean you're never going to use those tests. Okay? So, for example, like back up here, I'm just going to scroll up for a minute. If they had put on some numbers on these triangles, so let's just say this one was 3, and this one was 15, and this one was 4, and this one was 20. You would have to check, are those sides proportional? Would they be? Because if you set those up, what are you going to get? 5 or 1/5, depending on how you set it up. Like if you put 4 over 20 and 3 over 15, those would both reduce to 1/5. If you take 20 over 4, 15 over 3, those would both divide to 5. So if they're giving you numbers like that, all I would need to see is like you write out a statement that shows those proportions you set up, like 20 over 4, 15 over 3, and say that they're equal to each other, and verify for yourself that they are indeed equal, and then be able to say those sides are proportional. So if you see a problem like that, it's okay to use those other 2 tests. We just didn't see one like that in our notes today. Do we have any questions on our proofs? All right.